This video is on projectile motion. Question 1. A marble is rolling along a horizontal tabletop, which is 94 centimeters above the floor when the marble reaches the edge of the table and then falls to the floor. How long will it take for the marble to strike the floor? So there are some things you need to learn about projectile motion. Number 1, we can separate horizontal motion from vertical motion. Number 2, this means that one equation uses only variables for horizontal motion or variables for vertical motion only. Number 3, we cannot use variables for both horizontal motion and vertical motion in one equation. Finally, number 4, horizontal motion and vertical motion are connected by time, so the same time could be used for both horizontal motion equations and vertical motion equations. For number 1, we want to know how long it takes for a marble to reach the floor. So let's take a look at these variables here. Y initial is 0.94 meters, V initial y is 0 meters per second, and acceleration y is minus 9.81 meters over second squared, because I'm saying positive y is up, negative y is down. So we're going to use this equation here, plug in for the variables that we know, and we're going to solve for time. 0.438 seconds. Notice I only used these variables. I didn't use these variables. Question number 2. A rifle bullet which has a mass of 57 grams is fired horizontally from a rifle which is held 94 centimeters above the floor with a velocity of 385 meters per second. How long will it take for the bullet to strike the floor? So we want to know the time it takes for the bullet to go from 94 centimeters above the floor to the surface. So once again, we're only going to focus on these variables. Y initial is 0.94 meters, Y final is 0. Acceleration is on the y-axis is 9.81 down. I'm saying positive y is up, so negative y is down. I get the same answer as number 1, 0.438 seconds. Question number 3. A marble is fired horizontally from a launching device attached to the edge of a tabletop, which is 94 centimeters above the floor. The marble then strikes the floor 2.35 meters from the edge of the table. Part A, how long will it take for the marble to reach the floor? So we want to know the time. Once again, problem 3A is like problem 2 and problem 1. We want to solve for time. Y initial is 0.94, Y final is 0, V initial y is 0, A sub y is minus 9.81. Because I'm saying positive y is up and negative y is down, acceleration is always towards the center of the earth. Part B, what's the initial velocity of the marble as it leaves the launching device? So we want the velocity in the x direction. Okay, so if you want the velocity in the x direction, we're going to use these variables here. X initial is 0, V initial x is V cosine of 0 degrees, A sub x is 0. It's always 0, so memorize it. So I let x final be 2.35 meters because this is given to us in the question. A sub x is 0. The time the object was in the air was solved for in part A, so we just solve for V sub x. Part C, what will be the horizontal velocity of the marble as it reaches the floor? We know A sub x is 0, so V sub x is a constant. The object always travels 5.37 meters per second every second of the horizontal direction. Part D, what would be the vertical velocity of the marble as it reaches the floor? We're going to use this equation here, and it says vertical velocity. So we're only going to look at vertical variables here. We're not going to look at horizontal variables. V final we don't know. V initial we know is 0 on the y-axis. A sub y is minus 9.81. V final is 0. Sorry, y final is 0 and y initial is 0.940. So solve for V final y, we get 4.29 meters per second down. It says velocity. Velocity has a number and a direction. So this is the number, the magnitude, and we got to figure out the direction with our own logic. It's going to go down as it strikes the floor. Part E, what would be the direction and magnitude of the velocity of the marble as it reaches the floor? So V is equal to the square root of V sub x squared plus V sub y squared. This is the Pythagorean triangle. So right triangle. V sub x is positive 5.37. V sub y is negative 4.29. So the magnitude is 6.87 meters per second. The direction here is 38.6 degrees south of east. Because this is south of east. It's going to the bottom right. Question 4. Salah throws a ball with an initial speed of 47 meters per second at an angle of 30 degrees north of east, 830 meters above the surface of the earth. So, we're given the initial velocity is 47 meters per second, 30 degrees north of east. So, we could break this down into V sub x and V sub y. V sub x here is 47 cosine 30. V sub y is 47 sine 30. This is thrown 830 meters above the surface of the earth. So x initial is 0, y initial is 830. A sub x is 0. It's always 0, so memorize it if there's no air resistance. A sub y is minus 9.81, because I'm saying positive y is up, so negative y is down. This is part A, just completing the table. Table is important. Part B, what would be the horizontal velocity and horizontal acceleration of the ball when it reaches its maximum height? At its maximum height, V sub x is a constant and A sub x is also a constant. It's always 0. So these numbers hold at the maximum height. Part C, what would be the vertical velocity and vertical acceleration of the ball when it reaches its maximum height? At the maximum height, the velocity in the y direction is 0 because it's not going up or down. And the earth is always pulling it down, pulling it down, pulling it down. So the acceleration on the y-axis is 9.81 down. So this is the solution for part C. Part D, how long will the ball be in the air for? It says how long will the ball be in the air. So just like the previous problem, we're only going to look at the variables for the vertical direction. So taking this equation, y initial is 830 meters from the question, y final is going to be 0 when it strikes the ground. A sub y is minus 9.81, v initial y is 23.5 meters per second. Where did we find 23.5 meters per second? We found it here. And we just solve for time. Part E, what would be the range of the ball? Range means horizontal distance. So If you want the horizontal distance, we need horizontal variables, okay? So part D and E use the same equation. D uses it for vertical, E uses it for horizontal. For horizontal, A sub x is 0. V initial x is 40.70. This is from part A. X initial is 0. This is from part A. The time the object is in the air for is 15.6 seconds. That's from part D. And we could solve for x final. Part F, what would be the maximum height of the ball from the surface of the earth after it is thrown? The maximum height of the ball from the surface of the earth. So this is a vertical motion thing. So this is why we use vertical variables. Notice there's no horizontal variables. We could solve for y final is 858. Part G, how long will it take for the ball to reach its maximum height after it is thrown? So once again, this is a vertical variable problem. And we could use this equation, v equals at plus u, where u is the initial velocity, v is the final velocity. Part H, how long does it take for the ball to reach 400 meters above the surface of the earth after it is thrown? Once again, we're going to use vertical variables, not horizontal variables. Part I, how high above the surface of the earth will the ball be 8 seconds after it is thrown? It says how high, so vertical variables. Part J, how far horizontally does the ball travel during the first 8 seconds after it is thrown? It says horizontally, so we're going to use horizontal variables. Now, I asks for vertical information after 8 seconds. J asks for I asks for vertical displacement after 8 seconds. J asks for horizontal displacement after 8 seconds. And K is asking for the velocity of the ball 8 seconds after it is thrown. So at 8 seconds, V sub x is 40.7 meters per second because V sub x is a constant, it doesn't change if there's no air resistance. V sub y, we have to calculate it to be minus 55. So V is going to be equal to 68.4. Because V sub x is positive 40.7, V sub y is minus 55.0 approximately. And then we could find the length of the hypotenuse to be about 68.4. And this figure is not drawn to scale, because 54.9 is longer than 40.7. Step 4, find the direction. It's 53.5 degrees south of east. Why is it south of east? Because this is positive on the horizontal, negative on the vertical. Part L, what will be the displacement of the ball 8 seconds after it's thrown? We could solve for x final. We could solve for y final. And then we get the displacement here to be about 350. Because x final is positive 326, y final is negative 126. So that's why it's going to be south of east here. Part M, use a pencil and ruler. Draw an acceleration versus time graph, a velocity versus time graph, and a speed versus time graph, a displacement versus time graph, and a distance versus time graph for the ball for both the horizontal direction and the vertical direction. So, horizontal motion, A sub x is 0. Horizontal speed and velocity, it's going to be constant. Horizontal distance and displacement traveled, it's going to look like this with an increasing slope. Because as time t increases, the distance traveled increases. Let's look at vertical motion. A sub y, it's going to be negative 9.81. V sub y, remember, it's thrown at an angle above the horizontal. So the velocity is positive, then it becomes 0, then it's negative when it starts going down. You know, speed is always positive. Displacement looks like this, and distance looks like this. Question 5. A projectile which has a mass of 5.50 kilograms is fired from the ground with an initial velocity of 169 meters per second at an angle of 23 degrees above the horizontal. So part A, complete the following table. This is the most important part of the problem. If you cannot do this, you're going to get the problem wrong. You need to separate the x variables and the y variables, the horizontal variables and the vertical variables. Part B, what would be the velocity of this projectile at the highest point of its projectile? At the highest point, v sub y is 0, and v sub x is constant. So v sub x is this, at the highest point, like it always is. And v sub y is changing. So v sub y is going to be 0 at its highest point. So using this Pythagorean equation, we get about 156 meters over second. Part C, what would be the total flight time of this projectile? Well, y initial is 0, y final is 0. A sub y we know from the table in part A. V initial y we know from the table in part A. And solve for time. 13.5 seconds. Part D, what would be the height of this projectile at the highest point of its trajectory? So these are vertical variables. We're going to solve for y final. Where did I get v initial y? This is from part A. It's at the highest point of the trajectory, so v final y is 0. Part E, what would be the range of this projectile, meaning the horizontal distance traveled? We're going to use horizontal variables. Part F, what would be the vertical velocity of this projectile 3.5 seconds after it has been fired? It says vertical velocity. So solve for v final y. Part G, what would be the horizontal velocity of this projectile 3.50 seconds after it has been fired? Solve for v sub x. Part H, what would be the direction and magnitude of the projectile's velocity 3.50 seconds after it has been fired? So v sub x and v sub y were solved for from previous two problems. So v sub x is positive, v sub y is positive. So we're going to get something that's going to be north of east. So the magnitude is 159 meters per second. The direction is 11.5 degrees north of east. Part I, what would be the height of this projectile 3.50 seconds after it has been fired? It says height. So we want vertical variables. Part J, how far downrange will the projectile be 3.50 seconds after it has been fired? It says downrange. So this means horizontal motion. The horizontal distance. So remember, you could get these variables from part A. Part K, what will be the final displacement of the projectile 3.50 seconds after the projectile has been fired? We found x final and y final from the previous two parts. And x final is positive, y final is positive, so we know that the direction is north of east. Question 6. A Spanish galleon enters a harbor defended by a cannon placed on top of a castle wall, which is 135 meters above the water level. The cannon have a known mussel velocity of 323 meters per second and are aimed 28 degrees above the horizontal. How far from the base of the castle wall will the galleon be within the range of the cannon? So we want to find this horizontal distance. So we need to complete the following table. And we need to determine the total time the cannon is in the air. So y final is 0, y initial is 135, and a sub y and v initial y we could determine from the table. The cannon is in the air for about 32 seconds. Now use this equation to determine the range. X final. So the range of the cannonball is about 9,170 meters. Question 7. A motorcycle is moving with a velocity of 36 meters per second when it encounters a ramp, which is 22 meters long and meets the horizontal at an angle of 13 degrees. The motorcycle goes up the incline without losing speed and flies off the end of the incline. Part A, draw a figure. Part B, how long after the motorcycle leaves the end of the ramp will the motorcycle land on the ground? So we need to determine the vertical height of this ramp. This is the vertical height of this ramp here. So plug in all the variables for this vertical variable equation to determine the time the motorcycle is in the air. Part C, how far from the end of the ramp will the motorcycle land on the ground? This is a horizontal variable problem. So solve for x final and only use horizontal variables. Part D, how high above the ground will the motorcycle be at its highest points? So we're going to use vertical variables. Question 8. Abraham throws a ball horizontally eastward with an initial speed of 22 meters per second from 830 meters above the surface of the earth. So part A, complete the table. Let's just let x initial be 0, y initial be 830. It's thrown horizontally, so theta is 0. Part B, how long will the ball be in the air for after it is thrown? So they want vertical variables, so we use a vertical equation. Part C, what will be the range of the ball? Range is horizontal distance, so we'll use horizontal variables. Part D, how long does it take for the ball to reach 400 meters above the surface of the earth after it's thrown? So that's vertical variables, vertical equation. Part E, how high above the surface of the earth will the ball be 8 seconds after it is thrown? Those are vertical variables, so use a vertical equation because it says how high, not how far. Part F, how far horizontally does the ball travel during the first 8 seconds after it is thrown? It says far horizontally, so we want horizontal variables and a horizontal equation. Part G, what will be the velocity of the ball 8 seconds after it's thrown? So, v sub x, 8 seconds after it is thrown, is 22 meters per second. V sub y, 8 seconds after it is thrown, is 78.48 meters per second downwards. So it's going to look something like this. 81.5 meters per second is the magnitude. The direction is south of east. Why is it south of east? Because horizontal is positive, vertical is negative. Part H, what will be the displacement of the ball 8 seconds after it is thrown? So, x final is 176 meters. Y final is minus 313.92 meters. Then we could draw this triangle to determine the hypotenuse. That's the magnitude. And we could use this equation to determine the direction. The direction is south of east because x final is positive and y final is negative. Question number 9. Lot throws a ball at an initial speed of 12 meters per second at an angle of 30 degrees south of east from 830 meters above the surface of the earth. So it's going to look something like this. Part A, complete the table. You notice the angle is negative 30 degrees because it's below the surface of the earth that it's thrown. Or below the horizontal. Part B, how long will the ball be in the air for? How long means vertical, so we need vertical variables in a vertical equation. Part C, what will be the range of the ball? Range means horizontal distance, meaning horizontal variables in a horizontal equation. Part D, how long after the ball is thrown does it take to reach 400 meters above the surface of the earth? So 400 meters above the surface of the earth is a vertical equation and vertical variables. Part E, how high above the surface of the earth will the ball be 4 seconds after it is thrown? So those are vertical equations and a vertical variable. Part F, how far horizontally does the ball travel during the first 4 seconds after it is thrown? And it says horizontally, so that's a horizontal equation and horizontal variables. Part G, what will be the velocity of the ball 4 seconds after it's thrown? First find v sub x after 4 seconds. V sub x is a constant. Then find v sub y 4 seconds after it's thrown. You see v sub x is positive, v sub y is negative, so we're going to get a triangle like this. So the hypotenuse is 46.4 meters per second, and theta is going to be south of east, just by looking at this triangle. What will be the displacement of the ball 4 seconds after it is thrown? So first find x final after 4 seconds, then find y final after 4 seconds. So x final is positive, y final is negative, so we get a triangle that looks like this. We could determine the displacement, which is the magnitude, and the direction. Question number 10. A 25 kilogram ball is thrown from the edge of a very tall building with an initial speed of 20 meters per second at an angle of 60 degrees north of east. There is an infinitely tall vertical wall 120 meters from the building. So part A, draw a figure. It's going to look something like this. Part B, complete the table. Part C, how much time does it take for the ball to hit the wall? So we're going to use this equation here. Part D. At which height above or below the original position where the ball is thrown will the ball hit the wall? It says at which height. So that means we're going to use a vertical equation with vertical variables. Part E. What will be the velocity of the ball when it reaches the wall? So first find v sub x when it reaches the wall. Find v sub y when it reaches the wall. We have a triangle that looks like this. V sub x is positive, v sub y is negative. We could obtain the magnitude, which is 101, and the direction, which is south of east. It's south of east because v sub x is positive, v sub y is negative. Part F, what will be the displacement of the ball when it hits the wall? Find the displacement horizontal. Find the displacement vertical. Draw a nice triangle to understand that the displacement's going to be south of east. Here's the magnitude 513. Here's the direction. 76.5 degrees south of east. Now take a break and play this video game.